everyone. I hope you all will be fine. So let us start our today's session. In our today's session, we are going to start the study of solubility product. So you see here what I have written about the solubility product. After that, I will explain it. Now, it is defined as the product of molar concentration of the ions formed in the saturated solution at a given temperature. So I think you all know that what is saturated solution. What is saturated solution? When the molar concentration of specific solute stops to dissolve. Okay, so at this condition the solution becomes saturated. So here raised to the power equal to the number of times each ions occurs in the equation for solubility equilibrium. So you see here one example I have written, like AgCl, that is going to dissociate into Ag and Cl negative. This is in a solid form. I have mentioned here AQ, means that is in a aqueous form. Now, so applying the law of chemical equilibrium. So here I am just giving you the one example. For this equation, like AgCl, that is going to dissociate into Ag positive and Cl negative. As you have to find out its K, so that will be the molar concentration of product Ag positive ion, molar concentration of Cl negative ion divided by the molar concentration of AgCl we have to write. So this AgCl that multiplies with this K. So now you can write there AgCl that is equal to molar concentration of Ag1 positive and the molar concentration of Cl1 negative. Okay. So now AgCl, here you can write there, that is to be K into constant. So that will be equal to the molar concentration of these two products, Ag ion and the chloride ion. So here that becomes the KSP, that we have to call it solubility product constant, and that will be equal to the product of the molar concentration of product. Okay, so that can be written in this way. So here you see here how it is to be find out the solubility product constant. Let S is the mole per liter, be the solubility of the salt. Let we are taking like different compound A2B3. So now I have taken AXBY. The molar concentration in saturated solution will be, like suppose I have written AXBY. This is the reactant. So that will decompose into XA raised to the power Y and YB raised to the power X. YB raised to the power X, because most probably valency is to be interchangeable. So we have to consider their solubility is to be XS and this in this case of YS. Okay. So, okay, now I am giving the one example in the simple way, as you can see. Suppose, let us take the one example for like Al2SO4 whole thrice. So, that is going to dissociate into 2Al3 positive plus 3SO4 2 negative. So, that will decompose in this way. So, now here the molar concentration, that in this case 2s raised to the power 2, that number goes into the power, and now here you can write into 3s raised to the power cube. So now, and that will be equal to KSP. So now you can write KSP, that is equal to 2 2s are 4. Now you can write 4s square into 3 3s are 9, 9 3s are 27, 27s cube. So 27 into 4, you can write the number, whatever the come, 27 into 4, 108. So you can write the 108s raised to the power 5. Okay, so that will be equal to KSP. Now it is to be used in the numerical problem. In this way you can find out the KSP. So now, so I have written there the few cases for you that will help you to understand. For a salt type AB, KSP that becomes S square and S becomes KSP raised to the power 1 by 2. For a salt type of AB2, KSP that becomes S cube. So now S is equals to KSP raised to the power 1 by 3. In terms of AB3, so KSP that will be equal to S raised to the power 4. S is equals to KSP raised to the power 1 by 4. So here as molar concentration or solubility means number of moles of solute dissolved in per liter of the saturated solution at a given temperature. That you have to know, numbers of moles of solute that dissolves in per liter of the saturated solution. Here saturated mean is very important. Okay, so here specifically I have written here the difference between solubility and the ionic product. So you see here what point I have written about the solubility product. It is the product of ionic concentration in saturated solution, but in terms of ionic product, it is the product of ionic concentration at any concentration. So simply you can say that solution will be unsaturated and here the solution will be saturated. That you have to know that. Okay, now the next case, it is applicable only for the saturated, but it is applicable for all types of solution. Okay, for different types of concentration. It has fixed value for a salt at constant temperature. Means solubility product constant that will have a fixed value for a specific solution. Okay, and here that value may be changes or vary with the change in temperature. Okay, so now after that, let us discuss few application about the solubility product. So the first application that I am going to discuss, calculation of a sparingly soluble salt like AgCl and the barium sulfate. So here we can find out the solubility of sparingly soluble salt with the help of solubility product. Next, it is to be of predicting the precipitation of reaction. But like suppose you are preparing any solution, how can you find out here the precipitation will take place? So the condition is to be there. If the ionic product is greater than the solubility product, then the precipitation occurs. Suppose you have to properly solve the numerical. You have to find out solubility product and ionic product. If ionic product is getting greater than the solubility product, then the precipitation will take place. If the ionic product is lesser than the solubility product, no precipitation takes place. Okay, so this will help you in the numerical problem to find out the precipitation process. Now the third application, the classification of basic radical into different groups in inorganic qualitative analysis is based upon the knowledge of solubility product of salt of these basic radical. So here that solubility product also help in the basic radical for different groups, specifically in inorganic qualitative analysis. That we will do in the practical portion also, that we will also discuss. So I hope you all have got it, what is solubility product and what are the applications of solubility product constant. Okay, that's all for today's session.